Hello, um, welcome back. Today we're going to be solving NeetCode's 150 valid palindrome. I'm skipping over some of the array problems for now because I do want to make sure I'm tackling other subjects in this roadmap. Let's go ahead and tackle valid palindrome. So given a string, return true if it is a palindrome, otherwise return false. And for reference, a palindrome is a string that reads the same forward and backward. It is also case sensitive and ignores all non-alphanumeric characters. I think that's important. It is also case insensitive. So that means whether it's lowercase or capital, it doesn't matter. That's important to note, as when we're comparing a W, uppercase W, and a lowercase w, perhaps they could be the same. So here you could see this one would return true, and ignores all non-alphanumeric characters, so this would ignore the question mark as well as spacing. So let's take an example here. Was it a car or a cat I saw? And if we read that backwards, it's was it a car or a cat I saw? So that reads forward and backwards. That makes sense. And so the way that we need to view it is we're actually reading the word as if they were all lower cases. It was all alphanumeric, and there were no spaces, which is a palindrome. Here we can see tab a cat. That would backwards be read tack a bat, so that would return false. Yeah, so this one sounds pretty straightforward. Essentially what we need to take note of are a couple of things here, right? When reading letters or comparing, when reading / comparing characters, only compare alphanumeric. When I'll just do when RC letters, when reading characters, it doesn't matter the casing, All right. I'm trying to think about how we can do this. So one way is, how can we handle this? I'll call it the string builder method. Essentially what we can do is run is basically loop through our string, and as we loop through it, we append all alphanumeric characters in lower form, or lowercase form. Then we basically compare the string front and backwards, and this should get us what we're looking for. So now let's go ahead and talk about space and time. So for space, we're essentially storing it into a new string, so that's O of n, and comparing the string front and backwards. Okay, so that doesn't impact anything. In terms of time, we're looping through the string, so that's O of n, and then we're comparing it frontwards and backwards, and to reverse it would be also O of n, so that's 2n, which ends up getting reduced to just O of n. How can we do this better? We could use a two-pointer approach, so essentially cutting the time by half, but that ends up being O of n. But let's go ahead and walk through it. So I guess a little bit more efficient technically would be doing a two-pointer approach where essentially we set left and right pointers. We start left at the beginning of the string and start right at the end of the string, and essentially increment / decrement left and right if non-alphanumeric, so that way we could avoid things like spaces and other characters, and then compare left and right as lower. So we could compare them. If not a match, return false. Otherwise, return true. Return true. Let's go ahead and talk about space and time here. So for space, we are having left and right pointers. We're essentially incrementing and decrementing left and right. So that's pretty constant. So that's O of 1. And then time, worst case, we have to go through all of it. So we're not actually cutting anything in half, so that would be O of n. Yeah, so this does look a little bit more efficient because we are essentially storing in constant memory. But as for time, it is roughly about the same, going around the size of the string. And because we have to kind of view every single letter, I am inclined to think that there's no other way, at least at the top of my mind, to actually make this a little bit more efficient. So let's go ahead and write this. So we got to initialize some left and right pointers. So left will be 0 and right would be the length of s minus 1. And so while left is less than or equal to right, compare when r as lowers. So we need to increment left if it is non-numeric. So while left dot is alphanum, I believe is a function in Python. While left is not, while not L is alphanum. We basically got to increment left, but this would be wrong. We got to do s at L. We would do L plus equals 1, while not s at right dot is alphanum. We essentially do r minus equals 1. So this way we're basically skipping over characters that don't match. If s at L does not dot lower, I think that's important because we need to be able to compare them. Dot is or dot lower does not equal return false, and we'll exit out of our function. Otherwise, we increment left and decrement right, and then we return true if it works. So let's go ahead and run through this. Let's use, was it a car? Yeah, let's use this. So in this example here, left is here, and right is all the way here, right? So while left doesn't equal right, that's true. While not SL is alphanum, that doesn't do anything. We're all right. So then this will decrement. While not, so if R lower, so W compare W, return false, that's won't execute. So then now we have A and A, okay, and we have S and S. Then we have blank, or we have space and space. This will increment. This will increment. Hit a car, I. Space, R would decrement, TT. Space, AA. CC, and so on. So this looks about right. Let's go ahead and run it. Okay, let me double check on, I believe there is string is alphanum. It's alnum. Is alnum, my bad. Is alnum. Let's go ahead and run that. And there we go. Yeah, looks good. Oop, we got a wrong answer. Oh, SL is Alno. Would this just be an exclamation mark? Is that what it's complaining about? Yeah, I don't think there's an exclamation mark in Python. Why did that one fail? So while on line 42, no, that's not it. SL is Alno. While not. Oh, index is out of range. Okay. Oh, okay, we need to double check that left is within the proper bounds. That makes sense. So while L is less than R, less than or equal to R, and R is greater than or equal to L. That makes sense. String is out of range. The length of S is greater than 0. What am I doing wrong here? So while S at position L, because we're incrementing it, while it's not is L num. Oh, it's because we could get over it, so I think what we have to do is this. Yeah. That way the second condition doesn't execute. Otherwise, we're going to be indexing into something that doesn't work. Right? Sheesh. What am I doing wrong? If? Okay, I get it. I feel like there's a better way to do this. Yeah, that's gonna work, but I'll accept that for now. Let's go ahead and look at the solution. Yeah, so they double checked this and not. Yeah, that makes sense. Okay. All right. Thank you.